How do we go from a model that we think is kind of static to something that's fully articulated? And today I'm going to talk to you about a product we have at 10 Things, which is the ability to kind of look at every possible area of articulation, every material, every joint, every part of the CAD model, and turn them into actual materials and joints and links and mates that would exist in various simulators. So here we're looking at a version of a robot designed by Murdad that I talked about in a previous video, and he also posted on LinkedIn about the publishing of these robots with URDF files and all the articulations fully working. This robot is quite a wonderful example of just beautiful, elegant design. Here it is inside of the CAD and OnShape, and so this is the yellow man. But if you look, there's a list of robots that you can also utilize, and we'll leave the link in the chat for the various robots that do exist. But the one that we're going to take a look at is this robot called the pedestal yellow man. We'll look at that in a minute. It's kind of loading in the background. The various robots. We'll take a look at the pedestal yellow man, which is this one, and also take a look at that inside of the URDF file itself. But what we're trying to accomplish is, as you can see here, there are, if we just expose these, we're going to show all of these, you'll see these are all the mates that it currently has. So if you think about that, there's some fasten mates and some uh, revolutes and continuous mates. I think there's just all revolutes. But you can see here, these are not all the articulations possible. There's one here, there's one here, there's one here. They take quite a bit of time to do this manually. You have to, hide some components, show some components, make sure you have an assembly. It's quite time intensive. What we want to get to is a place where it's not time intensive and you get back all of the possible articulations plus possibly more depending on what the how liberal you let the models try to run themselves. And so at 10 Things we've created this product harness workflow, and what it does, and I'm going to show it in a minute, what it does is it takes a look at the entirety of the CAD model and your description and says, all right, it looks like you're supposed to have more articulations. We will, make the articulations that you asked for. If the materials are wrong, say you really wanted this to be, say, some kind of soft cloth material, you could, take this exact part and turn that part into exactly what you wanted to do for the various simulators that you want to run. So say you wanted to export this to a URDF, then it would function as it's supposed to function. So we're going to keep this video kind of short, just to show you what the output of something like this looks like. Um, I'm going to go to that particular project and let me continue on that project. And what you'll see is if we go to the CAD source, it tells you exactly what the CAD source is, what you're trying to accomplish. You can type in kind of what you're trying to tell the harness to do, and you can do that on the left or the right. This is kind of a chat view, and this view is more of a workflow wizard. And I'll just quickly run over what these things do. So here's where you're going to say, this is what I wanted to have happen. Copy the provided OnShape assembly, missing mates before repair, and export for safe copy. And then, so it needs to create a plan. And so it'll create an MCP plan in which it'll inspect the model that we're trying to use. It'll then go ahead and copy it over time. Let me just show you the results. They're not exact. You have actually more articulations than is possible by a little bit. But I'd rather have more and have them be exact than less. To make something like this, would take you quite a while to go through each joint and each link and make sure that it's absolutely perfect. So in this case, this is something that the MCP tools and your favorite model will be able to do by doing a series of kind of taking a look at the the robot, all of its joints and links and all of those things that exist, all the mates, all the places where it looks like there should be mates, and it'll add those in. Let's just make something move. So that's usually the most exciting things about when people see my videos. You can take, let's say, this whole wrist and move the wrist. And yes, I'm showing you the transformations on purpose, but we can also hide those, and then we won't see the transformations at all, and then still go back, and you can see that some of the things will move. And something like this would take you quite a while if you, so there's the shoulder roll. It will kind of misname some things, like that's the neck turning right there. But these are things that I would rather definitely deal with, um, or having some joints that, so here's the fingers moving. I'd rather have some extra joints that I can simplify rather than joints that would now be permanent, you know, um, that would take me a long time to fix. So there's the shoulder movement, and on and on and on. So the naming is something that still you still probably want to go back and name some things again, because I like to say left X, left blah 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 blah, instead of the way that it wants to interpolate these kinds of things. But the idea is dead on. So like to create that finger movement and to have it be nearly the correct joint limits is one giant step that you don't want to kind of redo again. So here is here are all the links that it's come up with, and joints. Like I said, they some of them might be not what you were expecting, but because the what it does is it looks through each part. If the part doesn't have any kind of naming that makes any kind of sense, like for instance, if there are not motors in here, or bearings or anything like that, it will think that this is not, a part that needs to articulate. So these are the kinds of things that still you would want to deal with this in your CAD model. But one of the more important parts about all of this is that now I have an exact CAD model from exact URDF from the CAD model. Nothing is simplified here in a way that you lose the fidelity of any of these parts. These joints here, if we look closely, the the transformation is exact here. The materials are exactly the way you had it before. The joints have been created and calculated in the way that you wanted them to actually show up in real life, versus what we do normally with the URDF file. We simplify it. So I'm gonna this kind of long video, so I'm gonna stop this here. But I did want to show you a little bit about what ends up happening here. As I do a readiness assessment, I have kind of told that there's going to be some expected links and expected joints, but it tells me then, it gives it a score of essentially what it thinks should happen when we export this URDF file. There's 113 parts, 115 mates, 13 unmatched parts, so it's going to have to fix that. And it said that the right arm has some issues, the left shoulder has some issues, expected some links, expected some other things. So it's going to go through with this plan and execute this plan. Well, I already done that, so we just saw the output of that, but it did go through and say, okay, these are the expected plans, and this is how we executed against the expected plan. Okay. And so we'll stop there, but I think this is a huge step in the right direction. And one of the things that can come out of this, and just to give you a little bit more um, look into 10 things, is one of the things that come out of this is now I can create an entirety of a code base based on the fact that I have the URDF file correct, I have the CAD model correct. Even if you don't give me a line of code and you tell me that the processor is a certain processor, or you tell me that you want to use maybe ROS2 and you're using a Jetson Orin, I can create the code that I need from 10 Things Discovery Hub, and that's something that we can go over at another time. But you can see here, it goes and finds, in this particular case, we're looking at, looks like a Unitree G1 with Inspire hands. Um, it'll go through and find all the potential capabilities that it thinks it should have based on the GitHub repos that are out there in the world, the CAD model, and some LLM understanding. So when you go in and you want to do something like robot control, so here's the Unitree robot. Now we have proper joints. We have joints and links straight from our CAD to URDF creator, which by the way works for OnShape today and Fusion 360, and likely very soon will be working for, so that's the left shoulder, pitch, yaw, and roll. There's that. And you see an error pop up on the screen because we